What's up, Calc Gang? CG. Find the sine, cosine, and tangent of 7 pi over 3. You can tell I'm getting real bored now. I'm going to start coming out with a new greeting every day. So we got sine, cosine, and tangent of 7 pi over 3. This is just the next progression in our notes. The first thing we need to think about is what 7 pi over 3 is. 7 pi over 3 is not on our unit circle. As a matter of fact, we have 5 pi over 3 here. That would be nice. So it tells us that it goes even further than this. So what we should think about is what 6 pi over 3 is. Because I don't know where 7 pi over 3 is, and I don't see 6 pi over 3. So let's think about what 6 pi over 3 is. 6 pi over 3 well, I could reduce that, and this would just be 2 pi. And where's 2 pi at on our unit circle? It's right here back at 0. 0 and 2 pi are the same thing. So if I'm doing 7 pi over 3, it's got to be further than a full circle, which then tells me that in order to find 7 pi over 3, the easiest way to do it is to then subtract 6 pi over 3 from that. Now, in the time that it takes me to write this out, Gloria, you should be able to come up with the answer. 7 minus 6 is 1. Very good, Glow. I don't know why I pick on you all the time. Just because you're such a great student. That's what it is. All right, so I got pi over 3. Now to find my sine, cosine, and tangent, that's a lot easier because I can just look at my unit circle. Pi over 3, that's going to be 1/2 for the cosine. Remember, the cosine is just the x values. So cosine of 7 pi over 3 equals, and that's just 1/2, sine of 7 pi over 3 equals root 3 over 2. And then if I'm looking at the tangent of 7 pi over 3 is sine over cosine. So it's going to be root 3 over 2 over 1/2. Anytime we have this, one fraction over another, remember we just flip the bottom and multiply. Top stays the same, root 3 over 2. Flip the bottom, that gives you 2 over 1. Those cancel. I'm left with square root of 3. You could have also just gone back to our table we did, I think 2 days ago, and that had that right in it. All right, so we're done with that one. On to the next. In exercises 1 through 6, I'm only doing 1 because, well, you're going to do 2 through 6. Find sine t, cosine t, and tan t when the terminal side of an angle of t radians passes through, t radians, I read that weird, when the terminal side of an angle of t radians passes through the given point. Okay, our point is 2, 7. So what that means is I should probably draw it. So I go right 2 and up 7. So it's there. And I can form my triangle now. Yep, that's perfectly at 2. See? Now my bottom number is 2. My side number is 7. So if I'm asked to find the sine of t and the cosine of t is just my x value, 2. My sine of t is 7. My tangent of t is just sine over cosine. That's it. Is there any need to really draw it? Only if you need to see, but otherwise not really. So 5 through 6 should be fairly easy. Made a jump. Number 7, I don't remember the instructions for, so let's hold on a second. It's exactly the same as the first one. So I need to find sine of t, cosine of t, and tangent t. Sine of t is 1 over the square root of 5. Can't leave it like that. Rationalize that denominator. Root 5, root 5. It gives me square root of 5 over 5. Cosine of t, that's negative 2 root 5, or negative 2 over root 5. Multiplied by root 5 on top and bottom. It gives you negative 2 root 5 over 5. And to find the tangent now, remember it's sine over cosine. So it's root 5 over negative 2 root 5 over 5. Flip the bottom one, leave the top the same. My root 5s will cancel. My 5s will cancel. I'm left with negative 1/2. And those are my final answers. All right, let's move on to the next one. Dang, how'd that get on there? Use the calculator in radian mode to find the sine, cosine, and tangent over each number. Round your answers to 4 decimal places. Use the signs of the functions to identify the quadrant of the terminal side of an angle of t radians. If the terminal side lies on an axis, identify which axis and where it is on, whether it is on the positive or negative side of the axis. That's a lot. Explain your reasoning. So the first thing we're going to do is use the calculator in radian mode. So we pull up Desmos. Hopefully you all know how to get here. Whenever you go to desmos.com, Math Tools, Scientific Calculator, brings this up. Flip that to radians mode, and now we are in business. Probably gonna better. Okay, it says we need to find sine, cosine, and tangent of each number. So sine of 7 pi over 5. Oops. Oh my gosh. There we go. Gives me negative 0.95. So the sine of this one gave me negative 0.95. Cosine, I should do this properly. Cosine of 7 pi over 5. I'm just going to go in here and make the switch. Just push backspace and put cos. It gives us negative 0.3. Then I can find the tangent of 7 pi over 5. Really racking up some parentheses here. And that gives me 3.07. It says use the sides of the function to identify the quadrant of the terminal side of an angle of t radians. If the terminal side lies on the x-axis, identify which axis and whether it is on the positive or negative side of the axis. Explain your reasoning. So using what we know about the sine and the cosine, remember our sine is all the y values and our cosine is on all the x values. Dang. I'm struggling. That's better. So if I'm looking at the coordinate plane, the fact that my sine is negative 0.95 tells me it's all down here. So it's got to be somewhere down here, not up here. So there's got to be something that's down here based on the sine. My cosine says it's negative. Remember, that's all your x values. So the cosine says it's got to be on the left side. Well, it's got to be in the red and it's got to be in the blue. So it's got to be in quadrant 3. Quadrant 3 is the only place where cosine and sine are both negative. Just as a refresher, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Oops, that's IV. So this one's in quadrant 3 because they're both negative, sine and cosine both being negative. What if cosine was positive and the sine was negative? It would have to be in quadrant 4 because all the x's are positive over here and all the y's are negative. If it's positive and positive, quadrant 1. If the cosine's negative and the sine is positive, it'd be in quadrant 2. Okay, this one gets a little more interesting because we need our unit circle for this. Dang, how did thumb come back? Remind me of somebody. That's why the thumb's on there. It reminds me of somebody. Okay, so when I'm doing this, I can look at the sine of pi over 6. Just using my unit circle, the sine of pi over 6 is 1/2. So this whole thing disappears and all I have left is 1/2. Then the cosine of pi over 2. Cosine of pi over 2 is 0. So I have 1/2 times 0 minus the cosine of pi over 6, root 3 over 2, and the sine of pi over 2, which is 1. Now we just use our order of operations. 1/2 times 0 is 0. Root 3 over 2 times 1 is root 3 over 2. I have 0 minus root 3 over 2. That gives me negative root 3 over 2. That's the final answer. Okay, over the next couple days, I'm going to give you some assignments on this, and that is about it for our trig section. We could do trig identities. I don't know that I really want to get into those right now, but we will get into them later as we're going through derivatives and things like that. So currently, this is how we're going to start calculus. I am going to give you a chapter test on everything we've done so far. So look for a review on that coming soon.